On question number 5, my first step is to get everything onto one side and 0 on the other. So I'm going to move the 5x squared and the negative 6x to the other side. So that will be x cubed minus 5x squared plus 6x is greater than 0. And then I need to factor this. So we should always try to take out a GCF first if possible. And x is common to all three terms here. So I'm going to factor out an x, leaving me with x squared minus 5x plus 6. And then I can factor that trinomial. Because there's no coefficient in front of the x squared term, we can just put x and x and really ask ourselves what two numbers multiply together to give me positive 6 but add together to give me negative 5. And that would be negative 2 and negative 3. So then if we were to set this equal to 0, you would get x is equal to 0 out here in front, x is equal to 2, and x is equal to 3. So those are my cutoff points for my number line. Okay, so I want to enter in this into my y1, and if you type in your cutoff points, you will see that they do equal 0, so that is definitely good. And then I need to pick points that lie in between the cutoff points. So you can pick any points that lie in between them. And if you plug in a negative 2, you get negative 40. So a negative 40, I care about the fact that that's negative. So this is going to be a negative region. If you plug in 1, you get 2, so that is a positive number. If you plug in 2.5, that is a negative number here. And if you plug in 4, you get a positive number. So now we need to determine which regions we want. And because it says greater than 0, that means that we want the positive regions, because positive numbers are greater than 0. And it's strictly greater than, so I'm not going to include the cutoff points. And that would be our final answer. So any number within these regions would make our original inequality true.